Uh, I think we are live now. Let just okay. Okay. So yesterday we have solved two problems. First one was group anagrams, and second one was encode and decode strings. Okay. So today we'll be solving picking up top k frequent elements as our first problem, and we'll pick product of array expect self as the second problem. As of now, I am just not taking easy problems into consideration. So let's jump into top k frequent elements problem. Okay, so I have also solved this problem previously. In 2022, I have solved it. Okay, so the problem says given an integer array nums and an integer k, return the k most frequent elements. You may return the answer in any order. Okay, so we need to return top k frequent elements. Okay, so in first example, let's just take first example. So frequency of 1 here is 3, frequency of 2 here is 2, and frequency of 3 here is 1. So basically we need to pick top two frequent elements. Sorry, frequency of 2 is 2. So 1 will be most frequent element as it occurs 3 times in the array, and 2 will be second most frequent element as it is occurring 2 times. Okay, So we have constraints of 10 raised to the power 5, uh, and our number num psi can be in between minus 10 raised to the power 4 and up to 10 raised to the power 4. Okay, given a random set. Okay. So we do also have a follow up. So first, let's just focus on the problem itself. So I think we also have a timer here, reset timer. I think okay. So timer is running now. So so let's start with the brute force approach. So we can calculate frequency of every element. For example, if I find one here, then I can calculate look for other ones in the array and mark these elements as visited and store this in a pair. For example, a pair of element and frequency. After first iteration, my pair array will have a pair 1 and 3. Then I will start with 2 and look for other 2's in the array. So and mark them as visited. So then my array will have this frequency. Okay, then I move to on to next index and uh, we'll check whether how many threes exist in the array, and as here only one three exists, so I'll take this element. And after getting this pair array, I need to sort my pair array based on frequency in decreasing order. I need most frequent element at the start of the array. So complexity of this approach will be, so iterating a array, full array will be big of n, as we'll be only visiting known visited elements, and after visiting array we are sorting our array, so overall complexity would be n log n. So let's just start implementing our approach. So initially, let's just define length of the nums array, which is n. Now we also need a list of pair, or we can call it as a list of array to store our element and its frequency pair. And also we need a visited array. Let's create a boolean array visited. of size n. Let's start iterating our array. So our current element is nums of I. We need to find nums of I in rest of the array. Our current frequency will be 1 for element. Now in rest of the array, starting from I plus 1. Wait, call is coming. हेलो. बता. Okay, so I think we were calculating frequency for the element. So if my nums of j equals my element, then I'll increase my frequency counter and also mark jth index as visited. If my ith index is visited here, then I'll be continuing here as it's already visited. I'll be looking for elements indexes which are not visited. Okay, so I've also marked it visited, and at the end I'll be adding a new pair to my list. Okay, so let's just let's define a answer array first. So we need to return a list of top frequent array of top frequent elements. So let's call this answer. And okay, so this size would be a as we size will be k as we need to return a k most frequent element, so its size will be k. So at the end we'll be returning our answer. So before, let's just see whether our list is filled with the correct pairs or not. So system dot, okay, so I need to iterate my list and system dot print, and let's just hit the run button. Okay, so we got a compilation error here. We need to mark it as true. Let's just run it again. Okay, so I have got 1 and 3, 2 and 2, 3 and 1. Means 1 has a frequency of 3, 2 has a frequency of 2, 3 has a frequency of 1. Same as this array. Okay, so now we need to sort our list. So we, as list is a part of collection, so there is a function in collections. Collections does sort list based on uh, this is a comparator. So we are providing our sort function a comparator that based on this comparator sort our array. For, by taking array A and B, compare element at first index in B to first element at first index in A. So that's how we will be sorting. And as we need top k frequent element, so we'll be taking so yeah, we'll be storing only taking top k frequent elements from the list, and then we'll be returning our answer. Let's just hit the okay. Let's just try submitting it. Okay, so it's faster than 5% solutions. So can we make it a bit faster? Can we optimize it? Let's just think. I'm thinking of using a priority queue, but also in priority queue, the time taken by algorithm will be n log n. So let's just approach. Let's just explore priority queue solution. So this was our brute force solution. We'll be needing this answer in future. So So let's define a priority queue. In priority queue solution will be straightforward. Instead of putting our frequency pair into the list, we'll be directly putting it into a priority queue, and at the end of the priority queue, we'll be popping out our top three elements. In priority queue, we'll be storing based on the frequency of the element. So at the end, we can just pop out three element from the priority queue, and that three element will be our most frequent element. So this solution, I guess, also will take n log n time, because inserting in a priority queue takes log n time, and we'll be inserting n elements, so n into n log n will be our overall time complexity. Popping from a priority queue is also a log n solution, also a log n operation. But the follow-up says that your algorithm's time complexity must be better than n log n, where n is the size of array. So how can we have a better time complexity than n log n? Is there any way that we don't need to add all the n elements into the array? No, we have to add all the elements into the array. 2.5 million accepted solutions. So there are a lot of ways to solve this problem. Hash table, divide and conquer, sorting, bucket sort, counting sort, select sort, heap, priority queue. I'm just talking about the priority queue solution. So what the divide and conquer says here? So is there any way top k frequent elements? I'm thinking that isn't there any way we can store only k elements in the priority queue? Would that make any difference? No, we have to store all the elements. Let's just first implement the priority queue approach. So let's define a priority queue. New priority queue. So I think by default, priority queues in Java are min priority queues. So we'll need. Okay, so we are defining a priority queue of an array, and as we defined a comparator in a list, we'll be defining same comparator in our uh, priority queue also. So this is the comparator. So what we'll be doing here is no, we cannot use. Then how we're gonna insert into the priority queue? Let's look at. So we don't have any hints. Let's look at the discussion what people are saying. I noticed that there is very little discussion. It all seems to be on their vision for the solution. There is a someone from 2016, nearly 8 years ago. Okay, so top k frequent elements. We can use a map to store elements in the map that will take big of n time, and then from map we can put elements into a list, and then we have to show that list. So this is the pretty same solution we have just implemented. Mm, I'm thinking of solution using priority queue. Let's look at my previous solutions. It was my first solution. So here I used a map. I have put all the elements into the map. Then I have implemented a function sort by value. Oh my god, what I have implemented. I have implemented a custom comparator. No, no, this is not the solution what I want. In July, then what I have done is I have sorted the array. Sorting array would take an log n time. Then I have put the elements into the priority queue and pulled k elements out of the array. Yeah, I can also implement this solution now also. In solution 2, using hash map and bucket sort. So what I have done in bucket sort, so I have stored all the frequency of all the elements in the map. Okay. Then I have created a bucket. Bucket is a list of integer arrays. Array of list of integer array. Max frequency can be n min 1, therefore Okay, for map.entry, reset. Okay, this was the approach I just submitted. I think the bucket short approach is the most efficient approach, but I am not able to understand it. So max frequency can be n, min can be 1, therefore. So I am checking a bucket of this frequency exists or not. If it doesn't exist, I'll add a phrases list here. Add key and add that bucket if already exists. Okay, basically my elements either can have one frequency or at max can have n frequency in the array. So what I'm creating is a bucket. Okay, so I have stored the elements in the list. Frequency list means elements having this frequency, and then I think I have started iterated. So this is a big of n approach, I think. Yeah, I have understood the approach. It's pretty good approach, I think. So let's just implement this bucket sort approach. So in bucket sort approach, what we'll be doing is we'll be creating a map where we'll be finding frequency of elements. For example, for the above array, this will be a map. This will be our map. That one having frequency 3, 2 having frequency 2, 3 having frequency 1. Then we will create a bucket. Bucket buck, the bucket of size m plus 1 at ith index where I is greater than equal to 1 and I is smaller than equal to n. We'll be storing elements having frequency I. Store elements having frequency I. Then we'll iterate this bucket from n to 1, and will stop when break when we find k elements. I think it's a pretty good approach. This will have a complexity of big of n. So let's just implement this bucket approach. So let n is size of our array. Map. This will be our frequency map. Map dot put element map dot get or default element 0 if not present, otherwise add 1 to its existing frequency. So now we need to create a bucket of list of integer, bucket of array of list of integer, bucket bucket. Now we need to iterate our map dot entry integer and integer map dot entry set. Okay, map dot entry set will check if our bucket at for a frequency value will be our frequency is null. If it's null, then we need to create a new list. Let's define this list here itself. List of integer list. So then we need to create a new list. And need to put that value into the list, and that need to put that list into the bucket of we need to put the key here. Otherwise if we already have our list present, then this will be our list. Sorry, get value. If we already have a list for that frequency, I think else my list will be UCKT bucket in the get value. Okay, then I have added this to my list. define our answer here. New answer will have size of k. Let's just return answer. Now we need to iterate our bucket from I is equals to 0. For I is 1, I greater than equals to 1, I minus minus. PUC KT bucket of I is not equal to null. Integer bucket I our initial index will be 0. And I need to add at my ITX index if my ITX becomes equal to k, then I have reached my whole element, so I can break here. I think that is it. Let's just run this code. Okay, so we have some issue, so this needs to be this needs to be this. Okay, let's just run again. Okay, so my index 2 is showing me out of bound. Index 2 out of bound for length 2. Okay, I also need to break the outer loop also. I think this will work. We need to also break outer loop also. This was fine as we are incrementing after the operation. Let's try submitting it. Yeah, so our solution is 91% faster after using bucket short. So I think this was pretty good approach. As our element can have this frequency only. Okay, so let's move to the next question. Hmm, I think this question is not available on LeetCode, or it will be in subscription category. Let's just see. Hmm, Problems. Product of array expect self. Product of, yeah, I think this question is also present in the on LeetCode, so we can solve it here itself. So I have just closed the LeetCode tab. Okay, what the fuck? Okay, so yeah, let's move back. Yeah. Mhm. Okay, so yeah, let's just read out the problem. The problem says, wait, it's 46 minutes. Given an integer array nums, return an array answer such that the answer I is equal to the product of all elements of nums. Expect the product and previous suffix is guaranteed to fit in. Okay, you must write an algorithm that runs in big of n time without using the division operator. Okay, so we need to find given an integer array nums, return an array answer such that answer I is equal to the product of all elements of num expects num of I. That runs in big of n time without using the division operator. So we don't need to use division operator here. For example, for this index, we have to find multiplication of all the other index. So 2 into 3, 6, 6, 4 ja 24. So 24 is the answer here. For the first index, we have to leave these two and multiply the remaining elements. For example, 1 into 3 into 4. So 1, 3, 12. So basically 12. So that's how we need to calculate. And also, we should write a algorithm which runs in big of n time, and also we don't need we without using division operation. I think one way is like we multiply one with all other elements. For example, 2, 3, 4. Then you will get 2 with all other elements. Expect 2 itself. Then you multiply 3. Mhm. It will not work. So we have constraints standard to other. Okay, so our numbers are between minus 30 and 30 only. So I think we can do something with bits. I think we Can you show the big of extra space complexity? The output array does not count as for space complexity analysis. Given an integer array nums, return an array answer such that answer I is equal to the product of all element nums. Expect nums of I. The product of any prefix or suffix of nums is guaranteed to fit in. Hmm, let me think. Let me think. We have array 1, 2, 3, 4. So in order to solve it using division, we just need to take multiplication of all these elements, which is 24, and then we just need to divide 24 with each element. For example, 24 by 3, 24 by 4. So but we are not allowed to use division. So is there any bit operation which uses division? 2, 3, 4. Guaranteed to fit in a 32, you must write an algorithm that runs in without using the division operation. Both things. इन स्क्वायर में तो पॉसिबल है ये Given an integer and nums, return an array answer such that answer I is equal to the product of all elements and exponential. You must write an algorithm that runs in big O and time and without using the division operator. We don't need to use. We don't need to use division operator. What's a division operator? Division operator divides. So how come we get to know the answer without looking at the answer? I think the key point to note here is that our numbers are in between minus 30 and 30 only. So 30 and minus 30 can be represented by bit mask. What's the use of bit mask here? 1 into 2, 2 into 3, 3 into 4. Let's look at the first hint. Think how you can use prefix and suffix product. Okay, so it is asking me to use prefix and suffix. For example, for this array, prefix will be 1, 2, 6, and 24. Suffix will be 4, 12, 24, 24. Mm, think how can you utilize prefix and suffix product to convert the product of. Okay, so I have product. Let's just extend our array. I think it's 120. Okay, so it's saying that uh, for this to find I need to find multiplication till this, okay, which will be 24, and multiplication till this will be 2. So 4 2s are 8. Okay, for this left element doesn't exist, so multiplication till this will be 120. For this multiplication will be 1 1 into 60. Okay, 65 for the 26. For this multiplication will be 6 into 5, 30. Okay, so we need both arrays. So let's say this is my prefix array and this is my suffix array. Okay, so in order to solve it in big of one space, so let's just take this example I have. Hmm, what I can do here is for this element I need this multiplication until here. Suffix and prefix. The output array does not count as extra space for space complexity analysis. If I will use different arrays of prefix and suffix, then I'll be using big of an extra space. I can use one array to can I means I need to compute both prefix and suffix using a single array. I can solve it using two arrays. That would be easy. I just need to calculate prefix array, suffix array, and for each index need to multiply left part. For each index, I need to multiply its left part to the right part. But how can I calculate this using a single array? I don't think Okay, I think I can use a variable to maintain a suffix or prefix till ith index. Let's start. So this will be our answer array. Let's first initialize the array. Okay, so I have this array. So answer of 0 will be nums of 0 4 int I equals to 1 I less than n I plus plus answer of I equals answer of I minus 1 into nums of I. Now, for example, my answer of 0 will be 1, then answer of 1 will be 1 into 2. So let's just print our answer array. So it's 1, 2, 6, 24. Yeah. So this is our prefix part. Okay, so this was the base condition. So this is now we need to start from the end. Prefix 1, 2, 6, 24, 120. Initial multiplication will be 1. It's more than 1. Plus plus. Let's just call this array as prefix. Prefix array, and last will be returning nums itself. So initial multiplier will be 1. And nums of I will be multiplier into Hmm. If I not equals to 0, then it would be no prefix of I minus 1, else it would be 1 into current multiplier. Then my multiplier increases as the current numbers of I. For example, for this 5, prefix of I minus 1, which is 24. Okay, into 1, take a 24. For this 4, it will be 5 into 630. So I think it's correct. Let's just run this code. Okay, so case 1, above prefix array will be 1, 2, 6, 4. Initial multiplier will be 1. So I minus 1, which is 6. Into multiplier. Then my multiplier becomes 4. Okay. Then for this number, 2 to multiply, let's just print out prefix array. Foreign element in prefix system dot out dot. Okay. So I think we have computed previous array perfectly. 1 into 2, 2. 1, 2, 6, 24. This is our prefix array, and 1, 2, 3, 4 is our nums array. So for this index, what I am doing is for n minus 1 index, my multiplier will be 1, 6 with 6. Okay, that's correct. Then my multiplier becomes 4. And for this index, to multiply. I think my multiplier is causing an issue. What's the issue with the multiplier? Let's just see. Initially it's giving 1. Okay, so I'm customizing my nums itself. So before customizing, I need my nums value, then I can need to assign temp to this. Then only I'll be able to find the correct answer. Okay, let's try submitting it. Perfect. Our solution is pretty much faster. Let's just look at the previous submissions. So what we have here in final approach. I think this is the same approach. I think we can end this stream now.